Okay, so to talk about exponents and roots, you definitely have a lot of experience with both of these. And we're going to go into some details that we just need to make sure we have established. When talking about vocabulary for exponents, instead of reading this expression just as 3 to the second and calling the 3 the big number and the 2 the small number, we have words to describe those. The first is the base. So the base is the number being used as the factor in this expression. The exponent, and then, is how many times the base is being used as a factor. So we have, and I'll just go show you on the next screen here. What does 3 to the second mean? Well, 3 is our base number, and the 2 here is our exponent. So when we say, what does this mean? What does an expression with exponents mean? It means repeated multiplication. So again, the base is what you're going to use as a factor, so we're going to use 3. The exponent is how many times you're going to use it as a factor. So we're going to use 3 as a factor twice and repeat that multiplication. So that's why 3 to the second is 9. So obviously, I mean, things that you are aware of, just making sure that vocabulary is reviewed. So 3 to the fourth, this is our I do, 3 times 3 times 3 times 3. Just to kind of throw some strategies out there that I know you've seen in the past, instead of saying to yourself, okay, what's 3 times 3 times another 3 times another 3? Remember, the associative property says that you can, with addition or multiplication, says you can group these how you want. So if I want to do some groupings here and say instead that 3 times 3 is 9, and 3 times 3 here is 9, and that the answer overall is 81, it might just be an easier way to get to the answer. So what I want you to do, remember, when we're doing these problems, you just think to yourself, okay, what's the exponent mean here? What does 2 to the fourth power mean? So for a pause and try this, you do on your own. If you're ready for the answer, remember the you do, or with the exponent here, it means repeat the base, repeat this 4 times. So 2/3 times 2/3 times 2/3 times 2/3. So again, you could still do that grouping. You could do 2 times 2. So if we're doing multiplication of fractions, we're multiplying the numerators. So that's 4 and 4. So the numerator is 16. And then the denominator, we already did 4 3s, and we know that that's equal to 81. If the fractions couldn't be simplified in the beginning, and we did the multiplication, there's no new factors that are going to simplify. So 16 over 81 is our answer. So here's the detail that comes in with doing exponents and comes in with doing roots as well, and that's paying attention to the negatives. So on this slide, it just says identify the base. So the base is what's going to be repeated. So 3, the power is working on the 8 here. It's telling you repeat the 8 3 times. Here it's saying repeat the 2 5 times. So the exponent belongs to whatever is directly in front of it. So what we really need to think of on the next 2 examples here, both that have negatives, is there a difference between using parentheses around that -3? What if there weren't parentheses? And the answer is there is a difference. When we look at the base on this with parentheses, the base is this entire number. It's -3. So when we're simplifying this, we're going to say, okay, -3 is what's being repeated as a factor. But when we look at the -7 raised to the 3rd power, what this is really saying, and maybe I should look back at the, well, I'll come back to the one with the parentheses. What this is really saying, and what the detail here is that the base is actually only the 7. Because -7 here, I could really write this as -1 times 7 to the 3rd power. That negative sign is really kind of like a multiplying the number by -1. I could do the same thing back for this example. I could say -1 times 3 to the 4th power. But if you notice, these parentheses mean that this exponent goes to both parts. The exponent's applied to both parts of that number, so whether you separate it out as -1 times 3 or you keep it as -3 repeating, it ends up being the exact same thing. So I could write this as -1 times 3 times -1 times 3 times -1 times 3 times -1 times 3. And it ends up being the exact same answer. But if I look at this one, the 3, the exponent, only applies to the 7. So the base in this question is only the 7. So the negative sign, whether you put a -1 or not, doesn't really matter, but the negative sign hangs out front, so if I do -1 times, and then what's repeating is the 7, and the 7, and the 7. So there is a big difference between parentheses or not. It's not just whatever you feel like doing. So for this I do here, again, what's the difference? The difference is the base. Here's what's repeating, and here's what's repeating. So the negative sign doesn't repeat because there's no parentheses. The exponent only acts on what's directly in front of it. This is a detail we'll see all throughout this year when it comes to dealing with exponents. So the 5 repeats, but not the negative sign. So this is -125. That's 25 times 5. And in this one, it's -5 times -5 times -5. Well, -5 times -5 is 25, times -5 is still -125. But how we got to those two different answers, it's important to distinguish between the two. Now it's time for your you do. So give these two a try. So for this one, again, because the parentheses are there, the exponent's acting on the entire thing. So this is really saying repeat, the factor that you're repeating is -1/4. So negative times a negative here is a positive, numerators, denominators, 1/16. In the second one, there's no parentheses. The 4 exponent is only acting on the 2. So the negative sign hangs out front, or is a -1, and the 2 repeats 4 times. So if we group these how we want, you have -1 times 4 times 4, which is -16. So those parentheses and locations of the negatives make a big difference. To go into a little bit about roots, reviewing about roots, square root, when we look at a square root as an operation, we're looking for a value that when you multiply it by itself gives the number. A lot of people mistake square roots with dividing a number in half. But square root of 9, you know this, is 3. Square root of 8, it's not 4, it's not half of 8. It's a number, it's what number times itself gives me 8. Well, that's not a whole number. It's a number that falls between, so if I did square root of 4 is 2, it's somewhere in between 2 and 3, but it's not exactly a whole number. So you've got it when you're doing roots, you really got to think through, just like exponents, what does this mean? When I take a square root, when I take an exponent. So perfect squares are those numbers whose positive square root is a whole number. So the numbers that you're familiar with, that you should have memorized, and realistically, I would expect you to have memorized the numbers, the perfect squares that fall between 0 and at least be familiar with or able to find those perfect squares that come between 0 and 200. And we'll go over those in just a second. But again, what does a square root mean? It means what number times itself is going to give you that value. So in that case, so square root of 16 is 4 Why is square root of 16 4? It's because 4 times 4, what number times itself gives you 16. So why can we find the square root of negative 16? So square root of negative 16. Well, we're looking for what number, some number, times itself that gives me negative 16. Well, why can't I find a number times itself that gives me negative 16? Well, that's because this negative sign. Because if I did, let's say I chose, well, it could be negative 4. Well, what's negative 4 times negative 4? Well, that's positive 16. 4 times 4, well, that's positive 16. So if a number has the same sign, or if a number times itself, they have the same sign, you're going to get a positive value. So the only way we can get negative 16 is by 4 and negative 4, but that's not what we're looking for. No pun intended. What about negative square root of 16? Well, this square root, what we have to realize is the square root sign acts almost like its own set of parentheses. So when I see a square root, I need to take that square root first and then worry about the negative sign. So in the first one, just looking at the differences, these are details. The negative sign's inside the square root, the negative sign's outside the square root. So what's the square root of, or the negative square root of 16? We'll take the square root of 16, which is 4, and then bring the negative sign along. So it's the order that you're looking at them and looking for those details. So if I do this, again, what does a square root mean? It means what times itself gives me 1/4. Well, to get 1/4, I would hope we could tell it's definitely going to have to be a fraction times itself. So what you want to think is, okay, how do I get to that 1/4? What times itself, and how do I multiply with fractions? Well, I multiply tops and bottoms. So I need to figure out individually what times itself gives me the 1 on top. Well, that would be a 1. That's the only way to get something times itself to give me 1. And then how about the denominator? How do I get that denominator? Well, it would have to be 2 times 2. So the square root of 1/4 is 1/2, because 1/2 times 1/2 is equal to 1/4. When it comes to square roots, you can think of it a little more simply. If it's a fraction, you can actually think of it just as, okay, let's take the square root of the numerator and the square root of the denominator separately. That's actually a property that we'll look at more towards the end of the year. So this is the last you do. I want you to pause and give it a try. But again, you want to take the square root at the top and square root at the bottom. Again, what fraction times itself? What fraction times itself gives you 9 over 25? Well, what gives you 9? 3. What gives you 25? 5. So the square root of 9 over 25 is 3/5. Perfect squares, I just want to make sure that you have your arsenal ready to go. So when we talk about perfect squares, and I said up to 200, I would expect you to be pretty familiar with this list. As I talk about numbers, these would be your perfect squares, because these are the numbers that when you take the square root, they are equal to no decimals involved. So that's 12, that's 13, and 14 I would give you if you didn't know off the top of your head. So roots and exponents, it's all about the details.